So this is all we had a look upon about the uh, Sucomax power and energy solution, which why it is needed, then how this kind of structure can really help you with a lot of load shedding, anticipating these startups, and even optimize and improving the PLC's energy source, or even the operating of production resources. All right, so then how actually we calculate the parameters, the alarm setting, the control unit, using a serial link directly connected to a PC or other control system. PLC function enables the following via logical inputs: to count impulses from electricity, water, or gas meters, to count the number of operations, or to check the position of a protection device or changeover switch, via relay outputs to remote control a protective tripping devices, change of status to remote control a motor startup or strip light, to shed load on parts of an electrical distribution system, changing a relay's brake state to control startup of a motor. To control count impulses from electrical, water, or gas meters, to count the number of operations, or to check the position of a protection device or changeover switch or relay outputs. To remote control a protective tripping device's change of status, to remote control a motor startup or strip light, to shed load on parts of an electrical distribution system. Right, so then we saw the how the 4 to 20 milliamps, or 4 to 20 milliamps, or 0 to 20 milliamps communication signal works. Then the digital communication part, open systems interconnection, ALS, and the I mean all the Sugomi products use 1, 2, and 7 layers. So we talked about physical layer, data link layer, application layer, then the medium, the protocols, the presentation, all these things, and yeah, this is what it is. Then we saw the RS-485 addresses. Then we had this, right, the length, the topology, the okay. All right, thank you so much for now. In the next session, we are going to talk about Profibus protocol. It's a little bit on that. All right, let's keep it separate, although it's just a continuity of RS-485 protocol. Or just we can have a look quickly. Presentation based on cyclic exchange between masters and slaves. The Profibus protocol can have several masters on the same bus. In this case, the method used is token passing between master and slave. The first master holds the token comes out, exchanges with the desired number of slaves, and then passes the token to the next master, which does the same. In this case, the method used is token passing between the master slave. The first master holds the token, carries out exchanges with the desired number of slaves, and then passes the token to the next master, which does the same. So masters, active complex devices, Profibus, this is calling this, and passing the token. Alright, beautiful. GSD file, the protocol is based on input and output exchange tables. The description of these tables, also called modules, is done via a GSD file provided by any Profibus slave. The production is based on input and output exchange tables. And there is a description of these tables, also called modules, is done via GSD file provided by any Profibus slave. The file describes the functioning of the slave in terms of this protocol. Functioning of the slave in terms of this protocol. The different versions: Profibus DP, manufacturing Socomac products. Application profiles such as identification systems, DP stack, DP V0 or V2, RS485. Profibus PA, process automation. Profibus DP is manufacturing. Application profiles such as PA equipment. DP stack, BPV1, MBP15. Motion control on Profibus drives. Application profiles such as Profi drive, DP stack, DPV1, RS485, Profi safe, universal. Application profiles such as Profi safe. Sorry. Alright. So this is what it is. Profi safe. Then as for any communication protocol, especially for field buses, Profibus is used on the OSI layers described above. As for any communication protocol, especially based on the OSI layers, in order to meet the requirements of different applications. 4 dedicated versions have been produced, each with their own specificity. Right. The Socomac range of products has Profibus DPV0 certification. It is therefore possible to connect these products on a Profibus DP bus. OSI layer 1 assures the physical transmission of data. It defines the electrical and mechanical characteristics, type of encoding, and standardized interface, RS485. Profibus specifies several versions of physical layers depending on the transmission modes conforming to international standards IEC 61158 and IC61784. The different versions are as follows: RS485 termination transmission, MBP transmission, RS485 IS transmission, optical fiber transmission. So Comac uses the RS485 serial link with the following characteristics: differential digital transmission, rate of 9600 to 1200 kilobits per second, two sheath twisted cables, differential digital transmission, rate of 9600 to 12000 kilobits per second, two shielded sheath twisted cables, linear topology without star network with bus transmission combination, up to 32 connectable stations with possibility to add repeaters. So Comac uses the RS485 serial link with the following characteristics: differential digital transmission, rate of 9600 to 12000 kilobits per second, two sheathed twisted cables, linear topology without star network with bus transmission, up to 32 connectable stations with possibility to add repeaters. It is highly recommended to use a standardized Profibus cable to secure transmissions. Please consult the following website for a selection of references. Procentec products cable index. Alright, so this is how we doing it. Alright, so see you next time. Next time we are going to talk about uh, we'll talk about oh my god, come on, what are you doing? Where you are on page, please remember that we are on page 76. So electrical measurement, we will talk about a little bit of the formulas, the accuracy class, copper losses, copper cable losses, then electrical measurement, summation transformers, digital prediction of networks. Alright, so we'll just go through all them. Thanks for now. This is all what we saw today. Until next time, take care. Bye bye. Thanks. Thank you so much. Thank you. Thank you. Thank you. Thank you.